This chart maps a collision course. AI chip production climbs vertically, while global electricity generation remains completely flat. We're manufacturing millions of processors without the electricity to turn them on. Running a single next-generation cluster requires 1 gigawatt of continuous power, dwarfing standard data centers. You can't just plug a gigawatt facility into the grid. Utility companies require interconnect studies that take over a year to complete. And if you try to build your own private power plant, you immediately hit a global supply chain backlog for gas turbine blades. The math is inescapable. The AI industry is scaling its computing demands far faster than human civilization can manufacture and permit the heavy hardware required to generate the electricity. Even if you somehow secure the electricity, physics imposes a secondary penalty. Jamming hundreds of thousands of processors into a single building generates an enormous amount of heat, which must be mitigated to prevent hardware from melting down. Look at that gigawatt in practice. To handle the hottest summer days, 40% of your energy is burned strictly on cooling. Factor in a 25% margin for maintenance, and you're left with a tiny fraction of energy actually powering the neural networks. Between grid stagnation, endless bureaucratic gridlock, and thermodynamic heat loss, attempting to build a terawatt of AI capacity on Earth is mathematically impossible. The energy simply bleeds out before it can be used. Moving those servers into Earth's orbit strips away the friction of the terrestrial environment. A solar panel floating in a vacuum operates at 5 times the effectiveness of one placed on the ground. There are no clouds to block the light, no seasonal weather changes, and no atmosphere to scatter the radiation. If you position the array high enough, you completely escape Earth's shadow. Without a day and night cycle, you eliminate the need to haul heavy, expensive lithium-ion battery banks into orbit to store power for the evening. The vacuum of space also functions as a natural heat sink. By exposing aluminum radiators to the freezing ambient temperatures of the cosmos, the 40% thermodynamic cooling tax disappears entirely. Shifting infrastructure to orbit provides the required physics bypass to solve the AI energy crisis. There is a major catch. If you send a standard, off-the-shelf processor into orbit, cosmic radiation will degrade and destroy the silicon almost instantly. To solve this, Tesla, SpaceX, and xAI have launched a $25 billion joint venture in Austin, Texas called TERRAFAB, designed from the ground up to manufacture space-ready hardware. The primary output of this facility is the D3 chip. It is a highly specialized architecture, physically hardened against radiation to survive and operate in deep space conditions. The scale of their orbital ambition is written into the production targets. A full 80% of TerraFab's computational output is allocated specifically for the sky. Elon Musk is abandoning the traditional TSMC and NVIDIA semiconductor supply chains, vertically integrating the entire chip design and fabrication process explicitly for orbital survival. Fabricating millions of radiation-hardened chips is only half the problem. You still have to haul terawatts of heavy silicon and aluminum radiators out of Earth's deep gravity well. TerraFab is designed to plug directly into SpaceX's heavy lift pipeline. The Starship rocket acts as a dedicated logistical conveyor belt for the data centers. The target deployment cadence is staggering. SpaceX plans to launch up to 10,000 times a year, filling low Earth orbit with a constellation of 1 million new satellites. Each of these units, known internally as an AI Sat Mini, operates as a self-contained 100-kilowatt computing node. Combine captive chip manufacturing with a captive fleet of heavy-lift rockets, you turn low Earth orbit into a privately owned, infinitely scalable server room. The pivot to orbital AI infrastructure represents a hard consensus across the tech sector. Google is spinning up Project Suncatcher, aiming to test their proprietary tensor processing units in space. Jeff Bezos pursues a parallel strategy through Blue Origin, developing the TerraWave satellite network. The best capitalized monopolies on the planet have looked at the math and reached the exact same conclusion. Competitive computing requires abandoning the terrestrial power grid. All of this infrastructure is racing to support the incoming era of agentic AI. We are moving from chatbots to autonomous digital systems capable of executing complex financial transactions and managing entire corporate workflows without human oversight. For these agents to replace human labor at scale, they must run continuously. That requires a massive, uninterrupted supply of incredibly cheap processing power. Tapping directly into the limitless solar energy of space removes the primary financial barrier to running these models 24 hours a day, 7 days a week. We have reached a hard transition point. The bottleneck to artificial intelligence is no longer software code. It's the physical fabrication of hardware and the generation of electricity. By pairing custom chip fabrication with infinite solar energy, the tech industry is severing its dependence on terrestrial bottlenecks. They are ensuring that human technological progress is no longer suffocated by the physical limits of Earth.